Hello all, welcome back to Data Science Brain. In this video, we will be doing a fun project where we will be making a virtual mouse using hand gestures. So we will be using libraries like OpenCV, MediaPipe for computer vision for doing this. So for a demo, as you can see, when I am moving my hands, the cursor of the mouse is moving. So now if I open my thumb, the mouse pointer will stop moving. And if I bend my middle finger, it will do a right click. And if now again I will close my thumb and let's do a left click, open the thumb and bend the index finger. It has done a left click. Again, close the thumb. We can move the mouse, open the thumb, stop moving, and left click. Okay, so that's what we are going to do. Okay, we will also do a screenshot. Just taken a screenshot. We will be able to see that in the code, the folder for the code. So let's get into the code. Okay, so let's get started with the code. So what do we need to know? So we need to get the video feed, right? So just like in the previous two projects, we need to get the video feed frame by frame in order to detect the hands and for doing all the gestures and everything. Okay, so first of all we need the video, isn't it? So for that, just like in the previous projects we have done, we will use OpenCV. Okay, so if you haven't watched my previous videos and if you haven't installed OpenCV, you have to pip install OpenCV. Okay, and doesn't matter whatever IDE you are using, you have to pip install OpenCV if you haven't installed it. Okay, so we will import it since I have already installed it, and I will run that import cv2. Now let us write a function. Let us write the main function and we will say def main. So we need to get the video, right? So frame by frame. So we will say capture is equal to cv2 dot video capture. We need to capture the video of from our camera. We'll say video cv2 dot video capture, and here we will pass in the number that represents the camera that we want to capture. Okay, so we have multiple cameras. Your number could range from 0 to any number. Okay, so if you have two camera, it could be 1 here. So since I am only using my primary camera here, I will pass in 0 here. Okay, if you only have one camera, just pass in 0 there. And now we will put the next few codes in try catch block, so that if at all any error occurs, uh, I mean it won't end the code. Okay, abruptly. Okay, so we will say while cap dot is open. So we are just checking if the capture is running successfully. If you are able to see the window, then we will get two things returned from cap dot read. So we are reading the video frame by frame here. Okay, so we are checking is the video open. Okay, then we are reading the video frame by frame here, and this will return two things: a return which is a boolean value and a frame. Okay, so the return, this boolean value will be either true or false depending on whether we are successfully able to read the frame. Okay, if we are able to read the frame, this will be true. If you're not able to read the frame, it will be false. Okay, and this frame will contain the frame at this particular millisecond or something like that. Okay, so that's what we are doing here. Now we will check if, so we only need to do the next few steps if we are able to return this frame, right? Otherwise we won't be able to do it. So we'll check if not returned, the boolean is false. If you haven't gotten the frame, we'll just break out of the loop. Okay, because we won't be able to do anything else if we won't get the frame, right? And otherwise we will just say frame is equal to cv2 dot flip. So I will tell you why we are doing this. So we are just flipping the frame so that it will just look like we are looking in a mirror. Okay, so this is just for convenience. This will make the video feed look like as if we are looking in a mirror. Okay, we are just mirroring the frame. Okay, that's all we are doing here, just for convenience. Okay, nothing important. And after that we will say cv2 dot, we will show the captured frame. Okay, we will use the imshow function from cv2 dot cv2 to show the frame that is captured. Okay, so we will name the window that is showing the video as frame, and we will pass in the frame that we have captured here into the function. And just like in the previous two videos, we will just say cv2 dot wait key. I will explain what this is doing in a minute. Wait key 1 and 0 x ff is equal to odd of q. We will break. Okay, so we are basically telling that just wait for 1 millisecond after each frame is read, and If the keyboard input in this wait period is Q, then break. So we are just telling the system, telling OpenCV that if I have pressed Q when you are waiting for that 1 millisecond after each frame, if I have pressed Q, just break it. So we are just using this to close the window. Okay, just close the whole process of video capturing. Okay, that's all what's happening here. Okay, and odd Q will take the ASCII value for Q. Okay, that's all. And in after the try block, we will say finally. So after we have finished, we need to release all the captures and everything. We'll say release, and we'll say we will destroy all the windows that the OpenCV have created. Okay, destroy all windows. Okay, so these are the two things that we will do after the try block. Okay, after we have run everything. So we will also write this here, if name equal to main. So we just, as I have explained in the previous two videos, we are just doing this to make sure that if you are importing this file to any other Python files, this function won't run. Okay, so it'll only run if you run this particular file. Okay, that's the only reason why we are doing this, and also for just to make it look better. Okay, so let us okay, we have encountered an issue. If c2 dot wait key, oh okay, equal to the other one was an assignment. This is how we check. Okay, so after running the code, as you can see, we are successfully able to see the video. Okay, so we are getting the video frame, and so that part is over. Okay, so what are we going to do now? So we have captured the video. Now we need to detect the hands, right? Detect the fingers in the hands, isn't it? You need to detect the thumb, all these points, the tips of index and middle finger, the thumb, the distance between the thumb and the index finger, to detecting the folding effect and all. And also we need to detect this, right? You need to detect the angle. Only then we can know, whether or not we have folded the index finger. Same for the middle finger, right? So we need to do all of these things, right? So as we have seen in the previous video, there is a library called MediaPipe, and it has a module called hands module, which allow us to detect these points, isn't it? It will allow us to detect all these endpoints and all these landmarks, which we can use for the making the virtual mouse. Okay, so let's do that first. So let us import MediaPipe now. So let us now import MediaPipe. We'll say import MediaPipe as MB, not NB. Okay, MB MediaPipe. And as we have done in the previous video, we will just do some initializations. Okay, so we will say mb hands is equal to mb dot solutions dot hands, small hands, and we'll say hands is equal to, we will set up the model first, mb dot okay, sorry, mb hands dot hands, and here we will set up our model. Okay, so just like we have done in the previous video, I'll just copy and paste some of those to save the time. Okay, so we have just set the static image mode to false, so because we are capturing the video here. Okay, and also we will set the model complexity to 1 to get a better model, and also we will set the min detection confidence to 0.7, which means that the minimum confidence score required for a hand detection to be considered valid is 0.7. Okay, and also we will set the min tracking confidence to 0.7 as well. So we are saying that only if you are more than 70% confidence that this is a detected hand, then only continue to track that detected hand. Okay, and we will also say the maximum number of hands that you have to detect is 1. Okay, because just for making a virtual mouse we only need 1 hand, right? So that's why this. Okay, in the previous video we have used, in the previous project we have used 2 hands. Okay, and here we will be using 1. Okay, so we have set up the model. We have done the initial setup and all. We will also do this draw. We know that this will help us to, from the previous video you know that this is helping us to draw the landmarks and everything. Okay, so I will show you how this MediaPipe library looks. So you can see the MediaPipe's hand module allows us to detect all the landmarks in a hand. Okay, so they will help us detect 21 landmarks in a hand. Okay, all the knuckle and all the points and everything, okay, the tip of the finger and all the bends and everything, okay. It will allow us to detect all these landmarks, okay. So this is what we need. So as you can see in the video, we need we have told you, I have told you that, whenever I am bending my thumb, the mouse will start moving, isn't it? Bending my thumb and index and middle finger is up in the upright position, the mouse will move. So for that we need to detect the distance between 4 and 5, isn't it? And also to detect bending of index finger and middle finger, we need to detect the angle between the 8th and 8th point and 5th point, right? So similarly like that, we can use this landmarks for our application, okay. So yeah, and after that, after setting up the model, now we will say frame. So we will pass our frame to the model. Before that we need to do some processing. We will say frame RGB is equal to cv2 dot cvt color. We'll pass in the frame. So MediaPipe requires the frame to be passed in as RGB format for processing and everything. And as we know, OpenCV by default captures the frame in BGR format, okay, blue green red format, but we need it in red, green and blue format, okay. So that's what we are doing here. Now after that we will pass it into the hands model, okay. So we will just create a variable to store the processed output. So we'll say processed is equal to hands dot process. We'll pass in our frame to the model that we have created, frame RGB. We'll pass that in here, and okay. And now we will set up a variable to receive all the landmarks, okay. Landmarks list, just a array to receive all the landmarks from the processed frame. So in this line of code, it will process the frame and detect all the landmarks from hands, okay. So this processed will contain all the landmarks, okay. So we need to get that from it, okay. So we'll say if processed dot multi hand landmarks, if it has detected landmarks from both the hands, we only need landmarks from the landmarks from one hand, okay. So we will take the landmarks from one hand here. We will say hand landmarks is equal to, so we are just saying if it has landmarks, if it has found landmarks, we will take the landmark from one of the hands, okay. We will say multi hand landmarks of 0, okay. We are taking the landmarks from one of the hands if it has detected. Now we will use the drawing utility to just to draw it so that you can see the landmarks and everything. This is just for convenience, okay, just to see it. Draw landmarks, and in that function we will pass in our frame. So we'll be drawing it on the original frame, okay, not the frame in the RGB format, in the BGR format, okay, the actual frame. And we will pass in the, what do we need to do? We need to draw hand landmarks, right? And in what format we need to what are we drawing? We are drawing the hand connections, okay. We are drawing the hand connections, okay. So we are passing in the frame where we need to draw it, and we are passing in what we need to draw and in which which type we need to draw, okay. So this will draw the hand landmarks and everything. Now we'll say we will loop through all the landmarks detected. So we'll loop through for, let's say, landmark lm for landmark in hand landmarks dot landmark. So we are taking in all the individual landmarks one by one, and we will push it in the landmarks list, okay. We'll say landmarks dot append, we'll say lm dot x, the xy coordinates of all the landmarks that has been detected, we will push it to the landmarks list, okay. So we have pushed it in not like this, we need to push it in a coordinate form, okay. So we have pushed it into the landmarks list, okay. Now let us print it and see how this will look like, okay. Just for demonstration, we will print the landmarks list. Let us print it here so that it will work after each capture. Okay, so let us now run this and see how this works. Okay, so as you can see, it is running, it is capturing the landmarks and everything, and it is drawing using the drawing utilities. And let us see the output here. So we'll just close it and see. As you can see, it has printed out all the landmarks, the position XY coordinates of all the landmarks that has been detected. It has printed out all of that. Okay, so you can see each frame contains 21 landmarks. Okay, for each frame it has printed an array of 21 landmarks. Okay, 21 XY coordinates. So it is working successfully. And now let us get back to work. So we have detected the landmarks, right? So now what do we need to do? I will again show you that. I will again show you the video feed to explain the next steps. So now we need to, as I have explained in the beginning of the video, when we are in this position, the mouse won't move. When we close the thumb and when the index and the thumb, index and the middle finger is in the upright position, the mouse pointer should move. So how can we detect that? So we need to detect this angle, isn't it? We need to detect the angle of the index finger, if it is bent or straight. And we need to detect the angle of the middle finger. And we also need to detect the distance between the tip of the thumb and the index finger, the bottom of the index finger, because we can see when we close the thumb, the distance between the tip of the thumb and the bottom part of the index finger is 0, right? Close to 0 or less than 50 maybe. Okay, so we need to detect the distance and the angle. So we need to write two functions for detecting angle between. So we are basically checking the angle between this line and this line, right? So this line and this line, this angle we need to check, right? So if we can get that angle, we will be able to know if the fingers are bent or not. Okay. Similarly, we need to get the distance between this xy coordinate and this xy coordinate, which we have already done in the previous project. Okay. So these are the things that we are going to do. Okay. So let's get started. So as we have discussed, we will write two functions, one for detecting the angle and one for detecting the distance. Okay. So for that, let us not make this code crowded. We will create a utility function. Okay. We'll create a utility Python file for this. Okay. So we will create a new file called util.py. Okay. And we will open that here. And in here we will write the functions, two functions, one for getting the angle and the other for getting the um, distance. Okay, so we will import numpy here. So numpy library will be okay, as numpy as nb will be used for getting the angle and also the distance. Okay, so we'll say get angle. So what angle do we need? We need angle of two lines, right? So I will explain how this works. Let me close these two. So as you can see on the screen, we need the angle of the index finger, right? So how can we get the angle of the index finger? So when we bend the index finger, as you can see here, you can see some of the bent fingers. We can see the point from which the finger will be bent is at 6, right? So 6 is the point where we actually bend the finger, right? So the bend happens at the point 6. So the angle will be created between the lines. I will draw it and show you. Angle will be created between these two lines, isn't it? The line between 6 and 8 and the line between 6 and 5. So the angle will be created between these two lines. Okay. So we need 3 points to get these two lines, right? We need 0.5, 0.6 and 0.8. So with these 3 points, we can get two lines. So let us say these 3 points are A, B and C. So we need A is 5, B is 6 and C is 8. Okay. So we need the distance between A, B and BC, isn't it? A, B and BC. Then we will be able to know whether or not the index finger is bent or not, isn't it? So that is what we are going to do. Okay. So let us just close this. So we need 3 points, right? So we need point A, B and C. As we have seen, we need 3 points to calculate the angle between AB and BC. Okay. So I will just write the code here and then I will explain what is going on here. So this is just mathematical formulas. So I will explain how this works. Okay, so we are basically taking the difference between the angle created by AB and x-axis and BC and x-axis. Okay, so in that way we will get the angle between AB and BC. Okay, so and after that, after calculating the angle between AB and BC in radians, we will convert that to actual angle by using NB dot absolute and NB dot degrees. Okay, so we'll convert it from radians to degrees. Okay, so I will explain how this mathematical calculation works. So basically, let us imagine the AB line is something like this. Okay, or let me draw it in red here. Let us imagine the AB line is this, and let us imagine the BC line is this. Okay, so this is A. Oh, it's pretty difficult to draw here. This is A, B, and C. Okay, so this is BC and this is AB. So what are we doing here? We are first calculating the distance between, I mean, the angle between AB and the x-axis. Okay, I will draw the x-axis here in different color. AB and the x-axis. Okay, this is the x-axis. So we are first calculating this angle. Okay, the angle between AB and x-axis. Okay, and similarly we are calculating the distance between, we will draw another x-axis here, or let us just use the same one. So we will do one thing, we will extend BC. Okay, we will extend BC, and so we are calculating the angle between, so now BC can be represented like this, it's the same line. So we are calculating the angle between AB and x-axis and BC, the angle that BC makes with x-axis. Okay, and by subtracting this bigger angle from this angle, we will get what? We will get the angle between AB and BC, right? As you can see, we were able to get angle between AB, this AB line, and BC line, isn't it? So I hope you understand. So we are basically doing what? We are basically calculating the angle between AB and then the angle between BC, and subtracting these two angles, we will get this angle. Okay, which is the angle that that AB makes with BC. Okay, so that's exactly what we are doing here. We are using the arctan function to calculate the angle that AB makes with x-axis and also BC makes with x-axis, and we are subtracting it here to get the angle between AB and BC. Okay, and then we are converting that in radians value to degree values here. Okay, so that's all we are doing here. Okay, simple max, and using simple max we are calculating the angle between two lines. Okay, now what do we need? Now we need the function to calculate the distance, isn't it? So we will say get distance. So this is, we have something that we have done in the previous video, so I won't go into much explanations here. So we'll say landmark list, and we'll say if the length, okay, if length of landmark list. So this same function we have used in the previous video. You can watch that video if you need to know more. So I will just be reusing that function. Okay, just there are just some minute changes, but it's a similar function. Okay, so we are basically saying if and only if there are two landmarks, I need to continue, because we need two landmarks to calculate distance, right? We need 2 points to calculate the Euclidean distance. Okay, and after that we are taking in the xy coordinates for the 2 points, because this is how we have stored the points in the landmark list, right? Okay, it's not it's list. Okay, this is how we have stored it in the landmark list function, and we are taking in the xy coordinates for the 2 points, and we are calculating the Euclidean distance using nb dot hypotenuse function. Okay, and after that we are returning it. Okay, we are also doing one interpolation here, because since we are getting this Euclidean distance as a value that is between 0 and 1, we are interpolating that to basically multiplying that to that with 1000. Okay, to convert that into a value between 0 and 100, or maybe a value that is little bit more comfortable to use. Okay, we are just using interpolate to do that. So these two functions will calculate the angle and the distance between 2 points. Okay, so the distance function we have done in the previous video. So now we have this util file, Python file. Now we will import that here, okay, for using in our project. So we will import util here. Okay, sorry. Okay. Now let us see if it is working. Okay, it has successfully imported util. Okay, so now we are able to use the get distance and get angle. So now what do we have here? We have the landmark list, right? The landmark list containing all the landmarks in our hands, all the fingers tip and all the landmarks. Now what do we need? Now we need to detect the gestures, right? So as we have seen, we have different gestures for different mouse movement, right? Different like for left click we have a particular gesture, for mouse movement we have a particular gesture, for right click we have particular gesture, for different actions we have different kinds of gestures, right? So now we will write a function to detect those gestures, okay? So we'll say detect gestures, and here we will pass in our original frame where we need to detect it, and we will pass in the landmark list, and we will also pass in the processed frame, okay? So this function will take in these three things, and it will detect the gestures, and it will also contain the code for actually moving the mouse and doing all the mouse actions, okay? So let us write this function detect gestures function here. Let us write def detect, let us just copy and paste it, detect gestures, okay? And we will say if the length of landmark list is greater than 21, greater than or equal to 21, then only we need to continue. Because why? Because even if we are not really bothering about the pinky finger and the other finger, we still need around 13 landmarks, right? For the index, middle finger and thumb, we still need around 13 landmarks, right? And even if in future maybe we will be expanding this visual mouse and adding more functionalities, we will need all the 21 landmarks, right? So that's why we are checking here, if and only if there are 21 landmarks, we need to continue, okay? So if it is there, first thing we need to do is we need to move the mouse, right? So the first action is movement of the mouse, and for that, how will we will be moving the mouse? We need a point, right? So we need the media pipe to track a point and map that point to the mouse pointer's location, right? So let us choose the index fingers tip as the xy coordinate for our for the mouse pointer, okay? So whenever I am moving my hand around, the index fingers xy coordinate is the position of the mouse, okay? It will be the position of the mouse, okay? So for that we need to get the index finger tip, right? Index finger tip. So we will get the index finger tip. We will write a function for that, find finger tip, and it will find the fingertip from the processed frame, okay? We'll pass in the process frame, and let us write that function here. We'll say def find fingertip, okay? So we will also check here if processed has multi-hand landmarks, just like this one, okay? The processed has multi-hand landmarks. We will get the, again it's the same thing, okay? We will get the landmarks here, and landmarks equal to, okay? And here's the code to get the index fingertip, okay? So we will get the index fingertip, or we can actually just return it here, okay? You don't have to say, you don't have to store it into another variable. So we will get the landmark, and from the landmark we need the index fingertip, right? So we have this kind of a variable, I mean variable which stores the index for the index fingertip, and that is the that is index fingertip in capital letter, okay? So this will contain the index for the index fingertip, and it will help us to get the index fingertip location, index fingertip xy coordinate. So we'll say mb hands dot hand landmark dot index fingertip, okay? We'll pass in this, and it will it will get us the a xy coordinate for the index fingertip. Okay, and this will also return none. Let us return none if there are no processed and landmarks. Okay, so that's about that function. Now maybe we can print it. Okay, maybe we can print it and see if we are able to get the index fingertip. Okay, so let us print it and see what we are getting here. We are running the code. Okay, let us see what it has printed here. As you can see, it has returned the x, y, and z coordinate. Z will be the depth. Okay, just means the depth, how for how far the finger is from the camera. Okay, and the x, y coordinate and the depth of the index finger it has printed. Okay, so we are successful in tracking the index finger. Okay, now we can move the mouse using this. Okay, so let's do that now. So since now we have the index finger tip, we can move the mouse using that. But there is one more condition, right? As I have shown in the demo, we need to close the thumb. Close the thumb, right? We need to close the thumb, only then the mouse will move, right? So for that, what do we need? How can we identify if the thumb is closed? By calculating the distance between thumb and index, right? Thumb index distance. So for that, we will use our utility function, right? We'll use util dot the get distance function from the utility file that we have created, and to that we will pass in what? We'll pass in the two landmarks for which we need to calculate the distance, right? So what are those two landmarks? We need to calculate the distance between the landmark 4 and 5, right? We need to calculate the distance between 4 and 5. This is the distance that we need to calculate, right? So let us pass in here from the landmark list. We need 4 and 5. Okay, so we need the distance between 4 and 5. So this will calculate that. And now what? Now if what? Now we are saying if the thumb and index distance is less than 50. So 50 means, basically it means that, this has moved closer to the base of the index finger. Okay, so as we know that, we have interpolated this to a value that ranges around 100. So we are checking if it is less than 50, then that means that, it is bent. Okay, so we are basically saying util dot no, we are basically saying if the thumb index distance is less than 50. Also we need one more condition, right? We also need to check whether or not our index finger is upright position, isn't it? So for that, what do we need? We need the get angle function, isn't it? So in to the get angle function, we need to pass in three values a, b, c to calculate the angle of that our index finger makes, isn't it? So what all are the points? The points are 5, 6, and 8. Okay, so to our get angle function, we will say util dot get angle. We will pass in the um, three landmarks. What are the three landmarks? 5, 6, and 8, right? So we will pass in 5, 6, and one more. 5, 6, and 8. So if this angle is greater than 90, greater than 90 means what? It is in the upright position, isn't it? So we are checking both conditions. We are checking if the distance between the thumb and the index finger is less than 50, means it is closer to the base of the index finger, and if the index finger is in the upright position greater than 90. Okay, then only what do we need to do? Now we need to move the mouse, isn't it? So we will say move mouse. Okay, using the according to the index finger tip. Okay, so now let us write the function for moving the mouse. Okay, it's a simple function. For that we need a library called PyAutoGUI. Okay, so if you haven't installed PyAutoGUI, then you have to install it. You have to install using pip install PyAutoGUI, and we will use this library for the mouse movement. Okay, so okay, so let us write that function. We'll say def move mouse, and if the index finger tip is not none. This is important whenever you are programming, okay, checking for null or none values, okay, otherwise you will be getting errors. And we will say the x coordinate, we will get the x coordinate of the index finger relative to the screen width. Okay, in the previous video I have told you that, so whatever coordinate values that we are getting, it is relative to the it is in range between 0 to 1. Okay, so we need to convert that to a value that is relative to the screen width. So for that we need to multiply that value that we are getting from MediaPipe with the actual screen width. Okay, so that is really important. Okay, so we are getting the index fingertips x-axis dot x, and we will multiply that with the actual screen width. Okay, so we can again use the PyAuto GUI library to get the um, screen width. Okay, so we'll get the screen width and screen height from PyAuto GUI dot size function. Size function from PyAuto GUI will get us the screen width and the screen height. Okay, so we have received both of that from this, and now we will multiply it with the screen width. So x-axis should be multiplied with screen width, and similarly the y value. Okay, similarly the y value will be multiplied with the what, screen height. Okay, so this will get us the actual position of the xy coordinate of the index finger in the screen. Okay, now what, now we have the position of index finger. Now we want to just move our mouse to this xy coordinate. Okay, so for that we'll say, we will call PyAuto GUI's function move to function will move the mouse to whatever xy coordinate we are telling it here. Okay, so we are telling move the mouse to the xy coordinate of our index finger tip. Okay, so that's all that. Let us now see if we are able to move the mouse. Okay, so now let us run all the cells and see if it is working. We might encounter some issues. Okay, we get, oh okay, yes, we have got some errors here. Get distance take one positional argument, but two were given. uh, Get distance take one positional argument, two were given. Oh, okay. So into the get distance function we need to pass it as an array. Okay, it takes it like this. Okay, now let us run it all again and see if it works. Another error. Landmark ist is not defined. What do you mean by that? Okay, yeah, this is the error. Let us save that and let us save all. So after fixing that landmark ist error, we have to restart the kernel. Okay, so we have to restart the kernel, because only then the changes that we have done to this file will be getting to this file. Okay, so we have to restart the kernel, and after that let us run it all again. And as you can see, now there is no error. Okay, and as you can see, we are successfully able to move the mouse. Okay, now let us open the thumb and see if it stops. Okay, yes, as you can see, when the thumb is in open position it will not move, and when we close it, it is moving. Okay, so, and also let us try and close the index and the, okay, yeah, even if the index and the middle finger is closed, then also the mouse won't move. Okay, so we need two conditions to be true for the mouse to move, that is index finger should be upright and the thumb should be closed. Okay, so it is successfully moving. Okay, according to the, and let us check to see if it is moving according to the index finger's position. Okay, by just keeping our hands in same position but moving the index finger. So you can see, yes, it is moving according to the position of the index finger. Okay, the tip of the index finger. So we have successfully implemented mouse movement using hand gestures. Okay, the first step is complete. Now we need left click, right click, double click, and screenshot. So let's get to that. So we have what now? We have the mouse movement enabled. Okay, so we are successfully able to move the mouse. Now let us do the left click. Okay, so left click. Okay, so we will say elif. So we need to check the conditions for the left click to be done. Okay, so what are the conditions for left click? So the conditions for left click are the thumb should be open, the thumb should be straight, and the index finger should bend. Okay, so index finger should bend, thumb should be straight, and middle finger should be straight. Okay, so middle finger straight, index finger bent, and thumb should be straight. Okay, so these are the conditions that we need to check. Okay, so um, what function can we use? So we can use the get distance function to see whether or not the thumb is straight, and the get angle function to check the check if index is bent, and also if middle finger is straight. Okay, so let us write a function for this. Okay, let us write a function for this. Let us write a function def is left click. Okay, so we will write that function, and this will get what? This will get landmark list land. Okay, let us just pass in here landmark list, and also the thumb index distance. Okay, because we have already calculated that, so we don't need to calculate that again. So this will get these two things, and it will return, what will it return? It will return after it checks the angle, right? It will return get angle. So first it will check whether or not the index finger is bent. Okay, so I will just copy the code for that. First it will check whether or not the index finger is bent. Okay, I think we have additional bracket there. See, in the index finger is bent, so this will check the angle between 5, 6 and 8. So 5, 6 and 8, so this line and this line, and it will check whether or not this is bent or not. Okay, less than 50. Okay, less than 50 degree, and you will check whether or not the uh, whether or not the middle finger is straight, so that is greater than 90. The middle finger is straight, and also the thumb index distance is greater than 550. That means the thumb is straight. Okay, thumb is open. So we are checking if index finger is we are checking if index finger is bent, if middle finger is straight, and the thumb is straight. Okay, so we are doing all three checks here. So similar to this, we will write functions for right click, double click, and screenshot. Okay, so I'm copying and pasting these functions for this. Since this all these functions work similarly, I won't go into it in detail, but I will just tell what is happening here. Okay, so similar to left click, in right click, what are the conditions? In right click, we need the thumb, we need the thumb to be straight, just like before, but the index finger should be open. Index finger should be straight, and the right and the middle finger should be bent. Okay, so for right click, the middle finger should be bent. So that is what we should be checking here. We are checking here if the index, if the middle finger is less than, the angle between 9, 10 and 10, 12, these two lines are less than 50. That means the middle finger is bent. We are checking if the middle finger is bent, if the index finger is up straight, and if the thumb is up straight. Okay, for right click. And for double click, what were the conditions? The thumb should be straight, but the both the index finger and the middle finger should be bent. Okay, so both the index finger and the middle finger should be having an angle that is less than 50. Okay, and also obviously the thumb should be having a distance that is greater than 50. Thumb should be straight. Okay, so that is for double click. And for screenshot, I am going to take a screenshot when all the index finger, thumb, and the middle finger is closed. Okay, so we are checking all of them are less than 50. Okay, all of them, the distance and the angles are less than 50. That means all the fingers will be closed. Okay, so we are primarily focusing only on the index, thumb, and the middle finger. We are not really bothered about the other two fingers. Okay, those fingers can do anything. Okay, so if all the index, middle, and the thumb are closed, we will take a screenshot. Okay, so these are the conditions, and we are using the utility function get angle for calculating the angle, and the we have already calculated the thumb index distance using the get distance function from the utility class. Okay, so so we have done all the functions for all the checks to see left click, right click, and double click. Now let us write the functionalities. Okay, now let us use these checks to check for left click and right click and double click and actually do those. Okay, so we will call the function is left click, the function that we have just written. Okay, we copy and paste it here. Okay, and to this we will pass in what? It takes landmark list and thumb index distance. Okay, it will take in these two things. And okay, so just let us write for all the functionalities. Okay, so I have written the checks for all the functionalities: left click, right click, and sorry, right click and double click and screenshot, by calling the functions that we have written here. That will check the angles and the distance and all. Okay, so we have this here. So if this condition is true, if we are ready for left click, we should do the left click. Okay, so for this we will use uh, a new package. Okay, we can actually do this using PyAuto GUI, but I have tested it, and I have tried it and found out that this different library that I'm going to use now is better for this particular clicking task. Okay, so for that we will import from PyInput dot mouse, we will import button and controller. Okay, and we will set up the controller here as well. Okay, let us just set it here. Okay, so we are importing PyInput dot mouse. If you haven't installed this before, you have to install this using pip. Okay, you have to install this using pip install PyInput, and then import button and controller from it. Okay, and we will use the controller for controlling the mouse. Okay, so let us import that and let us run these two cells, and after that we will use that. Okay, so we will use that to press the mouse dot press. We'll use that controller to press the left button. Okay, button dot left. So this will do the action for left click. Okay, so soon after that we need to release it, right? So how does a left click work? A left click works when we click on it and release it soon. Okay, so release, and which one do we need to release? We need to release the left click. Okay, so we'll click on it and we will release it quickly when is left click is returning true. Okay, so if the gestures for left click is correct, we will press the button and release it quickly to get a left click action. Okay, yeah. Okay, so let us write it for the right click as well, and then we will demonstrate. We'll say right, similar to left click. Okay, now that we have done for these two, let us just test it. Before that, we need to write it also. Okay, we will use OpenCV to put a text on the frame, just so that we can see that we are actually clicking um, left click or right click. Okay, so we'll just use put text. You know this from the previous projects. Put text is used to put a text on the frame. Okay, so we will use put text and we will pass in our frame and the text left click, and we are here we are saying we need to draw it on a position that is 50 pixel from the top left corner. Okay, and we are also here saying the font that we need to use, and also the color and the thickness and all those things. Okay, so this is just that, and we are just putting a text here. Okay, so similarly we will put a text here, and I'll just copy and paste the text for this. Okay, so for right click we will use a different color. Okay, so let us now just check and see if this is working correct. Okay, so we have encountered some errors here. It says landmark list is not defined, so you have to be really careful when you are typing on, especially on Jupyter Lab or Jupyter Notebook. Okay, because it doesn't give us any support for the spelling mistake and all. Okay, and that's where actually using something like something like PyCharm or maybe VS Code is better. Okay, because those will give us this spelling mistake errors. Okay, and this is just some silly mistakes. I have actually labeled it differently in different places. Okay, that was stupid. Okay, I think it won't give any errors now. Let us see. Okay, it's not giving us any errors. So as you can see, the mouse is moving, and if I open the thumb, it will stop moving. And let us see if we are able to click, right click. Yes, we were able to click it, but we won't be able to see the return thing. So let us click. Yeah, we are able to see the right click. I mean, yeah, right click and also the left click. Okay, so right click, left click, right click, left click. Okay, so it is working. So we are able to move the mouse, right click on it, and stop moving, left click, and left click. Okay, so we are able to do that. Okay, so yeah, this video is getting a bit longer. So we have successfully able to left click and right click. So now let us just quickly do the double click and the screenshot. I will just copy and paste the function that I have already written. Okay, and I will then explain it. It is similar to it. You already know how to do left click and right click by now. So it is just same thing, similar thing, just a few different functions. So yeah, I'll just copy and paste them. So for double click, we will use another function from actually PyAutoGUI. Okay, so for left click and right click, we have used this library PyInput mouse. But for double click, we will be coming back to PyAutoGUI because that is more precise. Okay, so you have to actually explore different libraries for different functionalities. Okay, because don't just rely on one library for all the functionalities just because it has it. Okay, you have to explore different libraries sometimes to see which one performs better on which task. Okay, so yeah, so for me personally, I have found that for double click PyAutoGUI does a better job. Okay, so that's why I have called PyAutoGUI double click for double clicking. After I have checked is double click returns true, and the conditions were both the index and the middle finger is closed. Okay, and the thumb remains open. Okay, and we have put the text for double click here in a different color. Okay, and for next, let us write the code for screenshot. Okay, so screenshot will be having a different code, a slightly different code. So for screenshot, again we are checking the conditions. What were the conditions? The conditions were the thumb, index, and the middle finger should be closed. Okay, so we have checked that condition, and if it is true, we are saying that the image, we are setting a variable im1, and we are getting the screenshot using screenshot function. Okay, so we are getting the screenshot here, and now we will take a label. Okay, so we will be taking multiple screenshot, right? So we need to save each screenshot with different labels. So for that, we are using a random number generator. It will generate a number, random number, that will be added to the label of the screenshot taken. Okay, so we will save the image im1.save, and we will pass in a formatted string here. This will be the name of the image saved. Okay, we will save as a png having a unique label. Okay, so that's all here, and we will put the text screenshot taken here. Okay, so now let us run it and see. Okay, so we have done all the functionalities: left click, right click, double click, and screenshot. Now let us see if all of these things are working together correctly. Okay, so let us run all cells. So we are here with the final demonstration of the project. So let us see. So yes, when the thumb is closed, we are able to move the mouse based on the XY coordinate of the index finger's tip. Okay, and whenever I open the thumb, okay, that is right click because the middle finger is closed. Okay, so whenever I open the thumb, the mouse movement stops. Okay, as you can see, the mouse movement stops, and whenever I close the index finger, it does left click. Okay, as you can see on the top left corner of the frame, it is saying left click. Okay, so when I bend the index, when I bend the middle finger, it does a right click. Okay, so now let us move it. Let us create a folder. Okay, let us stop, left click, move, stop, left click. We have created a folder. Okay, now let us delete that folder. Okay, so move, stop, right click, move, stop, left click. So we have successfully deleted that folder. Okay, so our functionality for left click, right click, and movement is working perfectly. Okay, so now let us check for double click. Okay, so let us now check the double click functionality. So we will move the mouse here. So we know that only when we double click on the drive, we will be able to open it. So let us stop movement, double click. So we have opened it, and let us open one of these folders again. stop, double click, opened it. Okay, you have to be a little bit quick there. Okay, yeah, so we were able to successfully open the drive and folder using double click. Okay, so double click is also working. Okay, now let us take the final thing, that will be the screenshot. Okay, now let us take the screenshot by folding everything. So it has taken the screenshot. Okay, now we will be able to see the screenshot in the folder here. As you can see, we have folded and kept it for some time. That's why it has taken multiple screenshots. So let us take one of these and see if it has successfully taken the screenshot. Okay, as you can see, okay, that was the moment after we have double clicked. Okay, so it has successfully taken the screenshot. Okay, so we were able to do all the functionalities as we have mentioned in the start of the tutorial, that is left click, right click, right click, and double click, and everything. Okay, we were able to do all of this, and we were able to do the screenshot as well. Okay, so that's all about the tutorial. I hope you have enjoyed it, and if you have liked it, kindly like, subscribe, and share this video with your friends. Okay, and watch my previous 2 tutorials on the same computer vision as well. Okay, so thanks for watching. See you in the next video.